So to introduce that part, let me first talk about how to visualize text. Now, when we talk about the visualization text, one of the common ways to visualize text is people create what we call the word cloud. And you will see in the next couple of sessions, we will talk about how words can be used as features in learning. So therefore, let me start with that one. For example, since we have used Python, maybe I can start with Python. Let's extract text in Python. So yeah, so we'll extract text available in a page like this, and then extract only the text part of it, and then let's see whether we can visualize. And when we say visualize, my plan is I'm going to highlight important words in this website. Okay, so there are a couple of website you can use. So the first one, as I told you, I'm going to start with the word cloud. So I'm going to read the first part would be like I have to read text information from the web. So we need like for that we can use URL lib, the request. So the idea is we can use this library to download the HTML content from the link. So therefore, I'm going to open it up. So I will say URL lib.request URL open. That's what we are going to do. And you can type whatever, the website that you want to use it. And the idea is we'll get the HTML content. So I'm going to use HTTP and let's say Python org, right? So let me take this as response. Right, so that's what we are going to take, right? And then let's take the HTML part. So for that one, what we do, so we say response.read. So let me say HTML equals response.read. And then you can just see print HTML, right? So once you do that, so you can see, you will get the HTML content, right? So the next thing that I'm going to use is maybe you can look at how the length of the HTML. So maybe instead of printing HTML, you have noticed that we have HTML here. I can see length of this. I can use len to see the, okay, so there was a bracket. Okay, we can get the length of the text. So we have 51,309. That's the length of the HTML content. Right. Now, so maybe I will share the code with you in the chat. Right. The next one, okay, I'm going to, what I'm going to do is simply, I will split and then I will take, the word by word. So the idea is we'll read it and then we'll get whatever we need from this, right? So there are many ways that you can actually do this. Reading from HTML, you can do it manually, just use split. There's a, if you take them as splitting, you can use, split command to do this. But since we are getting this as a HTML, the best thing would be you use a clean version of the words. So therefore, I'm going to clean tokenized version I'm going to use. Let me use, there's a library called Beautiful Soup, and we can use that to extract this one. So we will get the clean text, and then that's what I'm going to use, right? So let's start with that one. Right. So I'm going to use HTML content first. Right now we say HTML. I'm going to use HTML content, and I'm going to decode it. And this is Unicode. Therefore, we use UTF-8. Right. Now, if you want to see like first couple of code, you can just read it. Like maybe I will put maybe small amount. Let me use to show you what we have. Right. You can say doc type. Maybe then. Right. You can notice what we have right now. So it looks like we get part of this. Now we decode it and we'll get it as a HTML content. Now we need to remove these tags. Now to remove these tags, I'm going to use a specialized library. That's what I mentioned earlier. So therefore, let me get that library. So I'm going to say okay, so what this particular method does, simply it clean the content, right? And I'm going to use HTML, and then we can actually get the clean text. So that's the plan to use this. So let me use that to clean the text. So the idea is I'm going to say soup, we will use the method beautiful soup. And then I'm providing the HTML content, and then we'll use HTML parser for this one. Right. And then what we are going to do is we are going to get a clean text. So to get the clean text, we will use soup dot clean, get text. So right now, if you print the clean text, you will notice compared to HTML content, you might have noticed earlier that it just show you with the tags. Now you can see, so all the tags were removed. There are a lot of spacing or empty strings are there, but it's clean, right? So that's what we will get. So we did a couple of things. We actually decode it in Unicode, and then we pass it and we get the clean text, right? And that's what we get. The next one is, now we are going to visualize this. I'm going to build, actually the plan is I'm going to get the frequencies, and then we are going to make it a graph. So for that, the next step would be that I need to split. So splitting, we can use split method. So for that, we are going to create a array for that. So let's try that next. So what I'm going to do, I'm going to make it tokens, and then I'm going to get each and every word. So for that, what we do, we will say each token for each token in the clean text. And we are going to use the split method. So what happens with the split method is it's split the word based on the white spaces. So it's remove all the white spaces and takes each of the tokens. So this should be clean underscore, sorry. Yeah, clean, right? Clean underscore, yes. So what we do is we separate the data for each of these based on the white spaces, and we'll take as a token, and then we'll put it to an, a list. So right now, if you print this, right? Now let me show you. Now you can see that each and every word is appeared like this. Right. Okay, let me show you. Let me give you the code for you. Right. Now, once we get this one, uh, we have now extracted text put into a lowercase form. Now I'm going to create some frequency distributed list. Now for that, what I'm going to do is simply I'm going to use NLTK library for that. Then we can calculate that one, right? So let's do that. Simply you can use various ways to create this. So let me give you a code for that. So what I'm going to do, so let's start going through each token in tokens, and the idea is then we'll take word at a time, and then uh, if particular token will see whether it's in a frequency list, right? Right now, if you use just this one, you can notice that it will print everything, right? Now, I want to create a frequency distribution. I want to have the word and then the frequency. For that, I will create a dictionary. Let me say, I'm going to say frequency uh, uh, distribution that we are going to take. Let's create an empty dictionary. Now, what I'm going to do is I'm going to check where that is available there. Otherwise, we are going to, edit up. So therefore, what I'm going to do here, so I will go through each and token and see whether it's in there inside. So if the token is in the frequency, this dictionary, if it is already there, then we increase that by 1. Otherwise, we'll make it 1. That means it's first appearance. Actually, I get the code for this. And then what happens, this will create this frequency list and then it will print it. So right now you can see welcome is just 1, 2 is 21, Python oak is 1, note is 1, while 3 and so on. So you will get all the frequencies. Now, once we get this one, now I can happily create this one. So for example, there are many things that we could do. For the time being, let's put it into a, let's it's, we'll sort first and then we'll put into a simple graph where we'll show, let's say, what are the 50 popular words in this text. Now, for that one, what I'm going to do, we can simply start with tokens, and there's a, now this is manually we did it. The same thing that we can do, right, with NLTK. And in an NLTK, we can also can be used to print as well. So for example, let me give you the code for this directly. Same thing that we can be done, but we are using natural language toolkit for this one. And this is the tokens that we have used earlier, and it will actually create a frequency distribution of this like what we did early, and it will just print it. So you can notice that so it's same thing can be done directly. right? And the other thing is, in this one, we can plot it. So I will give you both codes. So for example, we can simply use a plot command, frequency distribution nltk.plot. And here the number specified, the first 50 frequent words can be used. So if you do that, you will notice that we get a graph like this. Right, now let me give the code first. Same thing that we have done earlier can be done in the NLTK library. And it also facilitates us to visualize it. So that's the difference why we are using this one. And with that one, we can directly visualize. So let me give you the code for this one. So I can, okay. So you can change the number of codes. So in this case, I will say, okay, so this is what I'm getting right now. So you can notice that Python is the most frequent words, and then we have a bunch of other words. So you can see there are some of the words are not very important, and in text processing, these are known as stop words. So if you remove, then you get much better outcome. Right, okay. So now that we have seen the 50 most frequent ones, right? So I can show you how to put into a graph, right? We have frequency distribution NLTK that we have used here. So which we can use that to visualize, right? So for that, I'm going to use the library. This is called word cloud, which is actually when you're giving the word and the frequencies, this will generate a graphic which highlight the text based on their frequencies. So for that, I will use word from word cloud, import word cloud. Right, that's one thing we want to use. Right. The next one is traditionally the MATLAB plotting library, which we have used earlier as well. Right. So first of all, we have to create the dictionary for this from that one, the format that need for this particular word cloud method. So let me create that word frequency distribution. What we are going to use word and frequencies. So this is the mode we need. We need word and a frequency in this form. So we are going to get this from we get word and the frequency from what we have generated earlier. And I hope you remember that this is a dictionary, and when you take items, you get the both terms and you separate them as word and frequencies and put it the form that you need it, right? So that's the first part. The second part, you will create word cloud. So we'll put, empty first, then we'll use later on. Now we use word cloud. We generate from frequencies. We'll use word frequency. Okay. And then we can say plt.show. Right. This is a simple one. Let's see what will happen. Okay, what? Okay, spelling mistakes, I guess. We have word cloud. Okay, it should be word. Okay. That's one mistake. One is missing here. We can have to say plt.im word cloud. Right. It will generate an image actually. So I have used underscore here. Right. You can notice that we are getting something like this based on this. So let me slightly improve this. We can switch off the axis. That is, we can see axis off. So if you run this now, there's no axis. We'll make it, we'll fix the width and height and the background color so that we can put it here. I can say width equals the size in pixels, height, let's use, and let's say background color. Let me use white. What about now? Okay. I think it's much better. We can specify the minimum size. Sometimes you might not be able to read the text size, the smaller ones, because it's dynamic. So let me fix that one as well. I will say minimum font size should be 10. So I have included that one as well. Maybe we'll line up. These are the values that I have used. Okay. So now this is much better. So if you want, you can change this. Let me say 14, for example. Yeah, you can notice the size effects. Right. I think now this one gives you our website content as a graphics. This is called a word cloud, and this is one way to visualize your data. And when you say visualization, here the word and the word sizes will show you the importance. So we have already noticed that Python was the most frequent word in that, and that's why you see in the large font size. But of course, there are other words which are not very useful for us that you have to remove. So there are some methods that actually we can use to pre-process text. I think we'll discuss those ideas separately and we'll come back and maybe we can improve this one. Right, now let me share the code with you. Now for that, let me first of all introduce the library. So the library that we are going to use called NLTK. And you will see that we are going to discuss many the methods from this library. First of all, let's take some data sets. The data sets also you can take it from the same library. So therefore, we will look at some data available there. So there's a project Gutenberg, which means that there are some free text available. So this is a place where there are a lot of free ebooks are there. And some of them are available through NLTK library, where you can use it for text processing. So let me share you like use of some of them. So the first of all, those things can be downloaded. So I will use download, and so the idea is you get the, sorry, it should be NLTK, and we get the required, the text. So for example, once you get this, and if you use so we are going to see like what are the texts available under this one. Should be file IDs, not fields. So you can see some texts are already available. Right. So what we have discussed here is we are going to learn some text processing. For that, we need some corpus, like we need some text data. And then we are going to get the text data from the NLTK library itself. And you can see there are some popular ebooks are there. Right. So let's take the first one, Stin Emma. That was one of the ebooks, which some of you might have already read it, which is quite common classic text. So let me show you the use of this for the text processing. Right. Okay. Now let's take the text from this. I'm going to get another code window. So I'm going to say I will say it's Emma text. I'm going to get the first ebook. It should be raw. And you can get a part of the ebook. So once we get the corpus from free books from Gutenberg, I have used the first text, and we will get NLTK corpus import Gutenberg, and then we will use the first text, Austin Emma, and we say that it's Emma text, and this is how we get the 500 first 500 characters. So the second one is you can use a split method, simply split based on the white space, right? That's one way to do is, and this is what is get the outcome, and you will see here. So bracket is also there, right? But if you use the second technique, you can notice we are using regular expressions, right? We use regular expression to split strings based on some particular pattern. And we are using capital W. Uh, this capital W means non-word character. So anything which is not a letter, digit, or underscore, then considers as W. And plus means one or more of these characters. So if you have none characters, then we'll separate out. So that's why you will notice that you don't see these because these are split points, right? All the other non-word characters, right, except underscore, digit, and letters, you use the splitties, right? So that's the second one you have noticed. Right. There are many ways that you can actually split as well. So for example, you can use white spaces and punctuations to remove. And then you can remove those punctuation from text. That is one way to do. So let me show you like one technique that we can use for the punctuations. So let's say we want to split by white space and punctuations. So we can use strings. And then, for example, let me first show you what we have in the punctuation. Right. So now we have used string to get the punctuation. The idea that I'm trying to do is we can use this punctuation to clean the text. That is one way to do. So all in any of these can be used to separate out, and we can remove them. So let me give you a code for doing this. Remove these from the existing words in manually. So for example, we can say words equals emma text dot split. So what happens here, we already know that we split based on the space. Right. Now, if you take words, it looks like this. Right. Now you can see in these words, these punctuations are always present, right? So you can have a look at the text. Where do you see some punctuations, right? Make a note of this. It's already available because it's split just with the space or white space. Right. So there's a function, there's a method that we can use. First of all, we define what punctuations are, then we can substitute them, right? For every word. So simply we are trying to remove, for example, here you can notice the square bracket, which I want to remove this. So for that, we will create something called transition table. So common usage. So I'm going to say punctuation transition table. So I already get the code. And then we'll go through each and every word in the words which we have created earlier. And then we'll remove, substitute them. And actually, I'm getting the code for that one as well. Maybe I can directly use that one. So what happens now? If you observe from previous one, you can notice that the punctuations were removed. So you can notice whatever the punctuations existing within within this were actually removed. So if you remember the words we have earlier, so for example, there were a couple of words, the punctuation characters were in the middle of the text. So that's, you can actually remove them. Right. Another processing technique that I wanted to discuss is the lower that we have already done. Maybe I will talk about this for the completeness. So I will use MR text again and split it on the spaces. And if you print words, it's look like this now. Right. The next one is, let's put them into a lowercase. So for example, I can say words. So it goes through each and every word and make it a lowercase here, which is again a common pre-processing technique that we have used. Right. Okay. So that's some of the techniques that we can actually use for manual text processing. And depend on your requirement, you might have to use these techniques, right? So the next part we are going to discuss, we are going to use NLTK library to split the text into word or sentences. The earlier we use to separate based only on words, but of course, we can make use of sentences as well. But how do you separate the sentences? You know that full stop can be used to mark the sentences. So let's see. So for that, I will use, NLTK library. So let me use from NLTK tokenize import. I'm going to first talk about sentence tokenize, which we have not discussed in manually. So the idea is we are going to separate sentences based on the text, and we print the sentences. So, okay, for that we need to download something. Okay, so first of all, we have to download these. So let me download first. Okay, to use this one, we have to first import NLTK and then import, NLTK download. Right, hope now it should work. Yes. Okay, now we'll run. Okay, what else? Okay, we have the tab as well. So we need one more. Right. Okay, now hopefully it should work. So first of all, use this one. I'll put it in the chat. Right. Once you do this, let's put up tokenizing and then it will print the sentences. And you can see that it's actually separate the sentences. You can have a look at the first sentence and second sentence. Okay, let's visualize the first sentence. So let me print only the first sentence, sentence 0, which gives the first sentence. Okay, sentences 0. You can notice that it goes from the beginning to the first full stop. And I think you understand why it is, because it's considered up to this point, from the start to this point as the first sentence. You don't have any issue when you take the second one. Second one is perfect, right? So I hope you understood the reason why we are getting like this. Because ideally, it uses a full stop to separate the sentences. So similar to sentence tokenize here, if you use word tokenize, you will get word by word. Next, we'll look at how to get or separate into words. So we can say from NLTK dot tokenize import word. Remember earlier we used sentences, word tokenize, and we can take word level, right? And you can notice that, so it's separated and we get word by word. Of course, there are few issues. You will notice that there are brackets, there are some commas. right? If you want to further clean this one, what you could do is maybe you can say, okay, you need only the text, right? So what I could do is, let's say, clean words. I want to clean the words. So what I'm going to do is I'm going to get the word for word in words. If word is alphanumeric, just observe our outcome from the previous one. So this time, if you look at it, the brackets, all the unnecessary punctuation were removed. Of course, if you go one step further, you can make it lowercase as well. So I hope you remember we use lowercase. So in one single shot, you can make it, both case. So what I did was from the previous one, instead of simply separate, I have checked whether the words are alphanumeric, which means we just ignore the numbers and all the other unnecessary punctuation characters. Although this is okay, you might notice that sometimes there are some words which are not very useful. For example, by. Even, I don't know, even I could be a problematic, right? Articles like the is problematic, it's appeared everywhere. So those things are not very useful. So maybe let's look at how we can actually remove them. Right? Let's just remove them. So how do you remove them? Okay, now we have clean words. We don't have anything, but still we have some stop words. Stop word means that they are commonly used in other places and maybe in everywhere. So for that, you have to use NLTK purpose. It's called stop words. So first of all, let's see what these stop words are. So I'm going to get these stop words. So let's take these stop words as a list. And we are going to use stop words for English. And maybe you can manually also create the list. Right. So if you print, you might see these stop words. Okay. One thing before that, we have to download these stop words. So let me download the stop words. And then, okay, now you can notice. So the idea of this is we can remove those words which are not very useful, right? Or which are commonly used in everywhere. So that's the idea that we are going to handle, right? So previous one, we have a clean words, but let's remove the stop words. So the idea is simple. We can say without stop words, I can say same thing we can do. What we have is right now clean words. We have clean words, right? So we can say, okay, we are going to get a word for word in clean words. If not, word in stop words. Actually, I'm getting the code, and then we'll print without stop words. So right now what we did, the previously we have separated the words, right? And then we consider only alphanumeric ones. We put it to a lowercase. Now we have removed what something called the stop words. And now we are getting something very useful. So if you look at what we have earlier, we have Emma by Jane Austen, volume 1, chapter 1, Emma, oh, you have everything, right? So now we have Emma, Jane Austen, volume, chapter, Emma. You see, some of these not very important ones were removed from the words. Okay, now you can go back and you can get the frequency distributions, right? And we can see what are the most common ones, right? So if you remember what we have done early, we actually use to display the graphic. I hope you remember we have used so I'm going to use that one here as well. Okay, so now that we have removed the stop words, so we can just get the frequency distribution. So let's say from NLTK probability import frequency distributions. So this is the method I'm going to use. I'm going to say, okay, frequently distributions NLTK. I will say frequency and then I'm going to use without stop words. Right. And then let's print it. Maybe I can say items. So you can see Emma is 860 times, Jane is 301, Austin 1, volume 3, and so on. Right. Now that we have, got this one, you can, if you want, you can visualize the most, important 50 words from the book, right? So maybe I will give you the code from the starting point. Okay, so this is not the sentences. I think we'll start with here. So we have tokenize, yes. So this is the tokenization. Right, that's the first part we did. We separate the words and then we kept only the characters. Right, and then we have separate what we call the stop words, which are commonly used, which is very not helpful. So that we have removed. And then we calculate the distributions. Right. Now the final one. Okay, now let's draw the first 50 most common words. Now for that, we can use the plot method we have discussed earlier. We say use plot, and let's say 50 right. Now that if you visualize, Okay, this is what you notice. So let's open that image, and this is what I have. Right. Let me put this one. If you look at here, you will see could and would and some of the words. You might be wondering why it is not included in the stop word list. So this is because the stop word list in NLTK is very minimal one. You can check this one. It's very minimal one. So that's the reason why you don't have. But if you want to improve this one, so what you could do is so instead of this one, you can customize it. For example, maybe I will do it after this. So I'll put it like this. So this stop word list, you can notice could and would is nothing added here because so they are not very interesting. Maybe you can remove. So that means you can actually make it custom. So what you can do is we can create our own custom stop word list. So I will say custom stop words, and we start with the NLTK default one, and we can update. So the idea is we can say custom stop word, and then we can say update, and then we can include like words like could and would. For the time being, I will use these two because you might be, if you're wondering why you are getting these two words, right? So you can notice this. So that's one way you use this. And once you use this, you can repeat the same process. So what you can do is instead of without stop words, maybe you can use custom stop words, right? So I'm going to use custom without stop words. Let me say version 2. I'm going to use custom stop words. Okay, I will use word 2, right? So you can notice that if you perform the same, now you should not see. So let me repeat the same. So now we have Emma, Jane, Austin, volume, chapter, and so on, right? What else? Handsome, clever, rich, comfortable, home, happy, disposition, and so on. Right. Let me see. Most frequent 51s. So this time, if you remove those two, so we have, okay, we have could, would. We have used could, would, right? Why? Okay. Okay, so we have to use V2, right? Okay, now you don't have. But we have must here. Much. So some of the things are there. So you got the point now, right? Maybe you can create your own custom stop word list to remove unwanted words like this. Right. So there are many other libraries as well if you want to use stop word list, and this is just a starting point. So I hope you get the point. Right. Now we come to the very last point that I want to discuss, and what you need for so machine learning. For example, let's say now that we have talked about how to pre-process text, right? The next point would be, how do you like make learning? For example, how do you perform text classification? Now, one of the problems we might face is text is a free. We don't have a structure, which means now we have to convert into a matrix form. Let me have a small theory, which I will explain how this could be handled, right? So here what I want to discuss is how simply text could be represented in matrix form. Right. Let me check. Right. Few ideas I would like to talk about in text classification. First of all, the idea of classification, we already know that we have to assign into, one or more categories, right? And we are discussing how we can actually transform this. And there are many applications areas. For example, emails we can classify as spam emails and non-spam emails. News we can classify it as political, entertainment, and so on. Web pages we can put into education and non-educational, and research papers into various different specializations and so on. There are many applications in the text. Right. What I want to highlight is how do you represent them? That means the document representation. And one thing is, if you look at just a simple web page like this, there are many things there. It's not just text. What are the things you will see? So you have text content, you have document structure, you have facts, and you have a layout. So hopefully, if you have seen the previous one, you have seen there's a title, you have a timestamp, you have main image, you have highlights. That is, everything is there. It's not just this. But of course, many of the time we focus on the text. So let me explain how the text could be transformed in a matrix form so that we can use whatever we have learned so far. For example, if you can convert this text document into matrix form where you have rows and columns, you know how to handle it, right? So the very first technique is called bag of words. That means document we can represent as a set of words, or we say bag of words, right? So the idea is we can convert, we can separate out words, and the words we can take them as features. Okay, let me explain this with a very toy problem. So let's say we have 3 documents, and let's assume that these are the texts we have. Let's say we have document 1, we have the dog sat on the floor. Document 2, we have the man sat on the floor, and the document 3, we have the man walk his dog. So ideally, when we want to represent them as a matrix form, we take these words as features, and you can find out how many times it appears in the text. So we put in the matrix form like this, and we look at how many times it appears. So when you say the dog sat on the floor, we know that the is there. Dog sat on the floor. So you can notice that the frequency counts. So for example, dog appears 1 time, floor 1 time, on 1 time, sat 1 time, the 2 times. So this is simply a bag of words representation. So you can count how many times the word appears and put into a matrix form like this. But one thing you have to be very careful. You have huge number of, words. So the problem with the text documents, it will be huge. The size will be very, very large, the vocabulary size. And some are more frequent, some are very infrequent. So we have to have a balance. When the word is more frequent, like word the, it appears in all the documents, which is not interesting. So you have to actually select what words are better in the representation. Second one, there are some words which are called stop words. We have seen this earlier. They are very common articles, things like that. We are very not useful. So ideally, we need to remove them. So that's what we do. Next, we have to, look for words in many forms. So, for example, we have words like house, houses, health, healthy, right? So we need to get the root node. So there are two ways that you can actually get the root node. There are stemmers. Stemmers means you remove suffixes like ending like ing, ed, etc. That is one way to do. The second one is called lemmatizers. Lemmatizer means that you can get the base form as a vocabulary, right? So once you use these are called the index terms. So you can use words as features, like what we have seen in the bag of words, or you can use phrases as features. Phrases mean, for example, if you take in front of, the three words goes together, right? You can use phrases. Or you can use n-grams. That means sequence of n words. For example, if you take single word, we say unigram. If you use two words, we say bigram. If you use three words, we say trigram. So you can use any of these techniques in the representation. So ideally, this is what will happen, right? We start with the document. We have a bunch of, text. We have other punctuation characters. We have to remove them, right? We have to convert it to one, case like lowercase. We have to remove stop words. We have to stem so that we get the base, and then we can actually use the matrix. And once you do that, we can use bag of words like representation like this, right? To represent your text data. There's other thing that I would like to discuss. First of all, a lot of words are there. So therefore, if you are planning to use text in text data, you have to select which text is very, very important. We call term selection, feature selection, right? So there are two ways that you can do. One is we call wrapper. That means you can use machine learning algorithm to select the best set of attributes. Second one, you can use some measurement like information gain. There are some measurements we use in machine learning. For example, information gain we use in the finding attribute in the root node, where it can purely separate at the root. So that could be a one measurement where you can see the importance of the attribute. So that is something that we need to discuss, or hopefully in the next class, I'm going to discuss this. Right. One last thing I want to discuss. I hope the bag of words are helpful for you and you understood how text can be represented. Right. One of the issues is, like articles like you can see it's appeared everywhere. And you have to remove it. And it's not easy. We have also noticed that you have to create a stop word list, and sometimes you have to create your own custom list as well. So there's another representation called term frequency, inverse document frequency, which considers how many times the term appears in the document and getting the inverse document frequency to handle this issue, right? So it's two statistics we use here. We have a term frequency as well as inverse document frequency, where we get how many times the total number of documents we divide by the number of documents contain particular word I. Right, now let me explain what this is. So term frequency means the same as bag of words. That means we know how many times word appears in each of these documents. So that's the term frequency. Document frequency means, right, how many documents you have with that particular word. For example, dog appears 2 times in 2 documents. So you have 2 here, right? And flow appears in 2 times. You have 2 here. His appears just 1 time, right? Man appears 2 times. On appears 2 times. Hat appears 2 times. The appears 3 times. In all the 3 documents, you see the. That's why it's 3. Work appears just 1 time. So we count how many documents contain each of these words. So this is called document frequency. Now, how do you count the inverse document frequency? So we have the document frequency, and inverse document frequency means you get log n is number of documents. In our case, it's 3. Divide by how many times the term appears in the document. So for the first one, we get 3 divided by 2. That is 0.176. Flow is also the same. His is 0.477 because you divide 3 by 1. 3 by 2, 3 by 2, 3 by 2. Okay, notice this one. Stop words like the appeared in all the documents, and this is what will happen. You have 3 by 3, which means this becomes 0. So for example, TF-IDF is really good handling most frequent words. Now, once you multiply, you get set of weights, and this is how we will get TF-IDF. Okay, so I think now briefly you might understand how we can represent. One is bag of words, one is TF-IDF. Right. Okay, it's almost 2:45.